Hi everyone, and welcome to the Ori Studio project. I recently posted on the Quantlib mailing list about my project, Ori Studio, and I've been asked by several people to do some kind of demo just to explain how it works, how the project is being set up, and so on. And so I thought it would be easier to just create something in YouTube. What I'll do as part of this demo as well is I'll provide a brief overview of who I am and what the project is and what we're trying to achieve with it. This is unscripted, so it's not going to be the best video ever, but hopefully it should at least allow us to put across the ideas behind the Ori Studio. So as you can see here, I'll put the link on the description notes of the video. As you can see here, this is the main project page. Pretty much everything you need is available either in this page or from this page. I try as much as possible to use AI, so a lot of the content, including the website and so on, is generated using AI. And so hopefully you can make use of some of the facilities we've got. So it's a C++23 project, which basically just means we're trying to use modern C++ as much as possible. Like I said, it's mainly generated using Cloud Code, although I've used other AIs in the past, such as Qwen and Gemini, but I've now settled on Claude. We try to use latest and greatest of everything. I try to update the compilers and the packages as quick as I can, so we don't really have to deal with too much issues with the legacy stuff. So at present our builds are red. I need to look into this, but you can see in C- the current status of the builds, and that's available here. I think mainly the problems we got at the moment are with Windows, just some kind of linking error, which I'll look into in a minute. But here you can see all the builds we do for the different platforms. We basically support Linux OS X and Windows, and we tend to have nightlies whenever there are commits. I'll just have to go back in time a little bit. So whenever there are enough commits in a day, we generate these nightly builds here. Just basically sort of standard C++ infrastructure, I guess. So what is Ori Studio? So Ori Studio is basically a wrapper, a UI wrapper, I guess, or service layer wrapper, because it's not just a UI around ORE. And I think it may be worthwhile for those that are not in the know about ORE, it's worthwhile also giving a quick blurb about ORE. So ORE, in fact, to be honest, let me just start from the beginning. So as you see here in my picture, there's a stack that we rely on, and this stack is basically Quantlib at the bottom, ORE in the middle, and Ori Studio at the top. So we start with Quantlib. So Quantlib is, I'll put the GitHub page here. Quantlib is a library that contains a huge amount of infrastructure around quantitative finance. It is very useful by itself, of course, and many things have been built using it, and we will be using Quantlib directly in the future, though we are not at present, but we will. But in some ways, for our perspective, it's a bit too low level. It's a bit like the different components of which you can make a car engine, but it's not a car engine, right? It contains all the primitives needed. It contains a lot of infrastructure around the quantitative finance domain, but it is up to you to then make use of that to then provide something at a higher level. That something is the risk engine, and the risk engine that's built on top of Quantlib is ORE, the open source risk engine. It's a very mature risk engine. It is a bit different if you come from a sort of a quant background, or if you come from a hedge fund or a bank. It may not be exactly like the sort of risk engines that you're using, because it seems to me, as a layperson anyway, to be more inspired with the approaches that we see a lot on market risk and credit risk and other more sort of back-end activities rather than front office. So my background is mainly intraday risk, and the kind of risk engines that I tend to work with tend to be a little bit different from open source, from ORI. But having said that, one of the purposes of the ORI Studio project is to test ORI's capabilities in the realm of intraday risk. So hopefully we will have more videos discussing that. I don't want to get too much into the weeds right now about that because I think that's a very complicated topic. But the crux of this explanation that we're trying to do here is that ORI is a risk engine, and it uses Quantlib to provide it with all the primitives needed to build a risk engine. And then on top of it, it provides an interface which is a much higher level to the users. And it enables you to think more in terms of sensitivities, in terms of measures, in terms of scenarios, which is kind of the right level at which you want to be thinking if you want to use a risk engine, rather than having to do everything yourself. So for all intents and purposes, you could use ORI without pretty much doing any C++ development as such. You can interface with it just via its sort of XML data interface. And we will do a lot of that in ORI Studio. Our Bible are the examples here in the ORI, and our objective is to make sure that every single example here is fully supported within ORI Studio. So the question naturally arises to why there is a need for a layer on top of ORI. In a normal system, in a normal exotics valuation system, you need a UI for the users to use so that they don't have to be dealing directly with the risk engine. And so that's exactly what ORI Studio is. ORI Studio provides you with a user interface that enables you to manage all the data, all the input data and output data of the risk engine. Now, in order to do that, it needs a service layer and it needs a database. So the database stores all the data, the service layer provides you with a service interface that the UI can use, and then the UI is the thing you use to actually manage the data. Now ORI Studio is not by any means a complete product. It's just got to the point where I feel comfortable enough that I can show it to other people. I've been working on it for a few months now. But it is still very early days. So what I'll do in this video is, again, it's all unscripted, so I'm sure there will be problems, but what I'll do in this video is I'll just show you how to set up ORI Studio and just some basic functionality, which, as you will see, it's got lots of shortcomings at present, but I don't think that the shortcomings that we got at present are huge, but unfortunately they stop you from being able to use it in a sort of end-to-end manner, as you'll see. But I think it is a good point now to start introducing to other people, because I think the architecture is now more or less in a good shape, and it's now a case of actually sorting out the problems, joining the dots rather than fundamental issues, I think. So our database is Postgres, and the very first thing we will do is we will set up the database. So what I'll do is I'm going to hop over to Emacs, which is what I use to do all the development. In fact, let me just show you a typical checkout of ORI Studio. So what I tend to do when I check out ORI Studio is I tend to create these environments. As you can see here, local 1, local 2, local 3, local 4. The system is designed to allow you to work on multiple environments. The reason why that's very useful is because I normally have multiple clones running on each environment, and they are completely isolated. So that's a good thing, because it means you can work on multiple feature branches simultaneously without trampling over each other's toes. And the system is designed and tested to an extent to work in this parallel sort of way. So in theory, you should be able to replicate this environment. In theory, I think if you just follow this naming convention of your checkouts and just do a dot something, that will become your environment name. Local is not the most creative of names, but that's the name I chose. Then here you've got other bits and pieces. The main one really is the ORI checkout, which we build, and then we use that to create the binary. In fact, you don't need to do that yourself, because if you look at a ORI Studio checkout and you look at the external directory, you'll see in the packages directory we have a build of ORI packaged here, which you can upload and then use that for valuation. So you don't necessarily need to build ORI, but I do advise you to, because ORI is so crucial to the whole project. So for our Postgres database, what we'll do is we'll just recreate the database. So here in Emacs, I mean, obviously you're probably not going to be using Emacs, but if you do Emacs, there's a mode that I created that enables you to interact with the database. And then here you can do whatever it is that you would like to do to the database. I've got a series of helpers. These are just calling scripts in the command line, so you could just call those scripts. The very first thing that I would like to talk about is the environment. So, and in fact, I will have to explain a little bit if you're not familiar with these notions of environments and Docker and so on. So, for anyone familiar with working on a sort of a production environment, you're probably used to things like Kubernetes, K8s as we used to call it, and you're used to all sorts of orchestration engines and message queuing and so on. I tried to avoid very much all of that complexity. In the beginning, ORE Studio used to be just a service and a UI, and I only moved to a non-monolithic architecture recently because it was becoming just too complicated to have a single service with so much functionality. So I introduced recently a message queue, but I want to introduce these things in a very incremental manner, and I would not like a system that requires you to set up K8s and then Docker and all sorts of other complex infrastructure just to be able to play with it. Now, I don't mean to say that you should not be able to do those things. If you would like to, there's no reason why. You shouldn't do it for yourself. Maybe you want to learn K8, so that probably is a good thing to do. But the project doesn't quite require it. You should be able to just use a plain Windows OS X or Linux machine, compile everything, start services, start the UI, and that's it. However, of course, in order to make the system compatible with a real environment, such an environment with Vault and all sorts of goodies that you need in a real production environment, we copied some of the ideas around it. And one of those ideas is this environment idea. So I will just press I here, and I'll generate an environment. And as you can see here, this runs a script. And this script sort of provisions everything for an environment. It allocates certificates and all sorts of things. But the crux of it is that in your top-level project directory, you will see that there's a .env file. And that env file is just a simple shell script. Sorry, Emacs is called shmod. Just a simple shell script, and what that shell script contains is a series of environment variables that configure the entire environment. These are just environment variables. It contains passwords generated with PWGen and so on. It makes it completely self-contained, including private keys and so on. Now, of course, you may say, well, you're making everything visible in terms of private keys and so on. This is just used for development purposes, right? So you generate one of these things, you sort of throw away, you delete it and recreate it, and away you go. It just doesn't really require you to worry about these things. In the real world, if you were running this in a production environment, your services will be in a Docker file. The Docker file will be picking up secrets from Vault or something like that, and that would then be exposing those to the environment. But this sort of enables us to replicate the bits of that system without any of the complexity. So all the stuff you see here is just generated on the fly whenever you want to create one of these. So if you ever get bored of your .env for whatever reason, if you think that there's any security issues or whatever it is, just rm the .env and recreate it using the script, which is this init environment script here. And it will create all the variables required to run the services. And then every other script sources a .env. So for example, if you're starting services or and so on, it will start services using that .env. Also note that the preset is a variable that we supply. So if you're building it using GCC or if you're building it with another permutation, then you just have to make sure the preset is set in order for it to create the environment with the right paths and so on. So once you've generated the env file, we should just go back to our databases here. The other things you can do here is you can recreate the database. So I'm just going to recreate this database. This takes a little while, so I'll just be talking while this is going on. So this is another shell script which uses the environment. It defaults to the current environment, so it will just create the database, as you can see here, the local one prefix that I mentioned before. It's going to go away. It's going to trash everything and then create everything from scratch. And once that's done, we can quickly log into the database just to have a quick look. as I said, these are all shell scripts. Emacs is not doing anything clever here. It's just plain shell scripts that are being executed. You can do this in shell. So for example, if I go here, let me just open up another shell, because I want this to be my service shell. Projectile shell, if I could spell. There we go. So we will just do our services here, and if I just go up to, I think it's in build scripts, and as you can see, there's a number of scripts here that we use. So as I mentioned before, the first component is a database, which is being recreated as we speak. It's just a plain Postgres database. Again, we use latest of everything, so the database is running using the latest version of Postgres. The setup that you need to do is you need to make sure you got a Postgres user, and you need to make sure that you can connect to Postgres and you know the password of that Postgres user. And then you can use that password to set up the environment. And then from then on, it creates all the roles, it does everything else. So that's going to go away. Unfortunately, there's a lot of database infrastructure, so it's going to take a little while. Seems to be getting close to it now. Just give it a few seconds. And it seems like the database recreation has been complete. Okay, so at this point in time we have a database. I don't really use tools other than Emacs, but I believe there is a UI for this, dbbeaver, something like this. I may have uninstalled this. Rarely, yes, I think I've uninstalled it. But if you don't particularly like Emacs, then instead of using Emacs, you could just use something like I think it's dbbeaver. I think yes, dbbeaver. It's got full Postgres support, and it's a bit nicer for those of us that like UIs. For me, Emacs is more than enough. So once we've created a database, we can log into it. Again, this is all helpers that I've created to make my life slightly easier within Emacs, so I don't have to type so much. And in here, you can see all the different database tables that we've created. Now, at this point in time, there's not much in the database, as you can imagine, because the system is been initialized. So what we'll do instead is we will just start services. So as I mentioned before, the system is always in a flux, so things change very quickly. So I have recently moved over to using NATS as the message queue and setting up multiple services. And again, because I didn't really want to rely on an external orchestration, you know, if you're using K8 or something like that, you get all of this for free. But of course, then you need to use K8. So I just created a really simple service, which is the controller service. And this controller service is just a C++ service that it's just very, very simple. It just knows how to start services and stop services and stuff like that. So it's not very featureful, but it just does the basics. And then you can use the status script if you want. This will tell you what's running. So you can see here at the moment we've got a small number of services running. We have our NAT service, not NAT server. I've created a separate NAT server per environment just to avoid problems. You don't need to, but I just did that. For those not familiar with NATs, just think of a very simple message queue that's just a single binary. You can run it locally, and it gives you most of the stuff you'd have in play, and things like Rabbit and so on. It's very, very simple, and it's quite easy to run on Windows OS X and Linux, unlike Rabbit that would require some installation steps and so on. NATS is really simple, just grab the binary and get going, so it's very easy. And then you just have a series of services you can see here. Now, the services are starting. I think this may actually be a bug, because I think by now the services should have started, but we will look into that in a second. So what I'm going to do next is I'm going to start the actual client. At present, we have a Qt client. I'm not much of a UI design person, so I just made the simplest possible UI I could have, particularly one I could make from using AI. So I'm sure you're not going to find it to be overly spectacular. By default in my development environment, I just use some sort of fixed passwords just to make my life easier. But of course, you should probably use PWGen and so on for this sort of stuff. What I've done is, it's useful to remember the passwords. Let me just go back here to connect. Sadly, I normally have a Portuguese and an English keyboard, and sometimes I make mistakes with the password. So one of the features in ORE Studio is it remembers your connections. So you can see here the different environments and the different things I've set up. I will see in a minute what these things mean. These are all the environments that I got: local 1, local 2, local 3, local 4. And then in the connection browser, once you've entered that password, you can then access the credentials of those things. So for now, we're just going to log into local 1 as a super admin, which is sort of the entry-level account. Now, the model that we chose for ORE Studio is a model of multi-tenant, multi-party. Now, this is not a common model for a normal exotics risk management system, so maybe I should give a quick overview on that. Part of it was because I also wanted to learn a bit more about this. Part of it was because, as with anyone else that's worked in a real hedge fund or a bank and spent many years in front office, one of the problems you must have had at some point was you needed to extend some part of the system that has been hard-coded to allow for things that it wasn't designed to do. The classic cases are your system starts as I mean, these days probably not so common, but when I started all those years ago, it was very common for a system to be not multi-currency. In other words, to have a single currency that was the core currency of the system, so for example GBP, and then suddenly somebody has a brilliant idea that you need to support multi-currency, and now you have to go through the entire system, change all the codes to be able to support multi-currency. The next thing that you probably bumped into is when you start with a single asset system, so for example you may start with a rate system, or you may start with a FX system or so on, and that system then has to be extended to support more than one asset class. Maybe it starts with only supporting spots and forwards, and then suddenly you need to have options and other exotics. Or maybe it's got support for a full product range of FX, but it doesn't have support for rates and so on. So that's the second problem that pretty much everyone bumps into. Then the third problem you tend to bump into is once you've gone through all those hurdles, the third problem is going to be you suddenly have more than one party, more than one internal party that you need to set up in the system. So the system has been hard-coded so that the house is fixed. And now suddenly you need to use that in multiple parties. And you can see this is sort of an abstraction ladder that we're climbing. And finally, the last step of the ladder would be you need to support multiple tenants with independent parties that are completely self-contained. So I decided to start this project coming from the other opposite angle. I decided to start with a completely generic approach that I then started to limit as I went along. So the system is designed to be multi-party, multi-tenant, multi-party, multi-asset class, I should say. And so that none of those things are hard-coded, they're just all data-driven. Now, of course, you may say, well, that's a bit ambitious. And in fact, I didn't quite realize, well, that's part of the learning process, I guess. Didn't quite realize the complexity of enabling that facility or the flexibility. And there are still bugs that we're finding as we go along, but it's more or less functional now, so we'll see some of that functionality. So when you log into the system, you log into what's called tenant zero. And the tenant zero is basically, well, you need to create some kind of tenant in the system in order to manage the system. So that's what we're going to do. And obviously, each tenant has got an admin, and the admin of tenant zero is the super admin. Again, to make life easier, we're just using these temporary passwords. You can set the passwords to whatever you like, but of course in development, and because you keep trashing databases every 5 minutes, I suggest just the development passwords to make your life easier. So in reality, we have an option here of single tenant and multi-tenants. This is sort of a fake choice, really. The system is always multi-tenant. The difference between single tenant and multi-tenant is just that we create tenant number 1 with a name called default, whereas in multi-tenant, you can actually configure the tenant properly. So I'm just going to choose multi-tenant, and I'm going to use, I always use some random corporation because we have support for GL, Gleif, GLEIF, which contains information from parties and so on. So it's just one way of testing the data. So we choose a random entity, like for example Barclays. And then here, to make our life easier, again I'm going to use our well-known password, which again, as I stress, is just a development password. In production, of course, you would have the usual security processes, right? So as you can see here, we created our first tenant. The tenant has an ID for the tenant, and the admin account has been created. So at this point in time, we're more or less finished with SuperAdmin. Should close that window too. One useful thing that you have in SuperAdmin as well is we have a service dashboard here, which shows you the services that we're running. At the moment, we're pretty much running with one replica for every service, and I must say I haven't tested this with multiple replicas really. But in the future, potentially, you could run this with multiple replicas. The only exception, of course, is the grid, where we're running with 5 replicas because we need multiple compute nodes. But you can see here all the services that are running. So what I'll do now is I'm going to go back to here, and I'm going to start another client with a different color. The color is just basically, it's just so I can tell the difference between the different instances that I've got of ORE Studio. And so in this client, what we'll do is we will log in using our tenant admin on the first tenant that we just generated. Now, as with the system itself, when you log into a new tenant, you also get a new tenant provisional wizard. This will start to initialize the tenant. So at the moment, we just put in a base system. The base system is basically contains all of the key entities such as currencies and so on, just to get you set up, because these are things, sort of ref data, that you don't necessarily need different ref data for everybody. So the base system is just a very quick way of getting all that working. And then, as I mentioned before, we have this Gleif registry, which I've downloaded a subset of. Gleif is very, very large, so I've downloaded a very small subset. And then what you can do is, once you've taken that subset, you can use that data. Now, you may be asking, why do we need the Gleif data? Well, one of the difficulties that you have when you're creating a new system, this is not a difficulty when you're doing this inside of a prop trading house or inside of a hedge fund or a bank. You have plenty of data, but in the outside world, you don't have so much data. And without that data, that wealth of data that we have in the outside, in the inside world, should I say, it's difficult to test the system. So what we try to do with ORE Studio is we try to make use of as much as possible of all the data that's available, open source, basically, data that you can use without a CC or other licenses that we can use to drive the system, because that gives us a good idea if we're going in the right direction or not. Because if you can't support real data sets, then it probably means you're missing some features, right? So anyway, we're just going to go to Gleif, and in Gleif we're going to pick up a root of related parties. In other words, Barclays is the root, and then there's a number of entities that are related via Gleif, and we're all going to pick all of those up. And that's a good thing to do because it's realistic. So then, as you see in a minute, it enables you to see something close to the real world. So now that we've done that and we've logged in as party admin, what we can do now is, I've mentioned before that there was a notion of tenant 0, which is basically a system tenant. There's also a notion of party 0, because in order for a tenant to exist, well, that's not quite true. There is a context in which you log in, and that context is always a party and a tenant. And you must always have a party. So as you've seen a second ago, we just generated the parties. But in order to do these operations as tenant admin, you needed some kind of party. So what you were logged into is you were logged into the system party, as you can see here. But that's not a real party, really. It's just a party there to do operations at the tenant level. So what we'll do is we'll just disconnect from that party, and then we will go back again to tenant admin. And as you can see here, we will log in. Now, because we've already initialized all the parties, you can now see that the login is a bit different. It's now saying, oh, you need to choose a party. Of course, you could choose a system party, and sometimes it's useful to do that. But if you want an actual operational party, you can choose a party from here. So what we'll do is we will just log into the root of the group. Now, just like we did for the system and for the tenants, we now have a wizard to initialize the party. So what we'll do is we will just do a few things in the party. The first thing is we will add counterparties for that party to trade against. And it will also create some kind of book structure. Again, this is all sort of test data really, because as you can imagine, I needed data to test the system. And because of course we're still in a very initial development phase, it's wise to, well, I haven't worried too much about non-test data, if you see what I mean. So I'm sure if you start to use this for other purposes, you may find some limitations, but what has been tested more thoroughly is the test data. So once you've done the initial counterparty setup, it also generates a number of reports. Now these reports, again, because we're still very early on in the development phase, these reports are some reports that between myself and AI we thought would be useful to have. We are not able to run these reports as such because we're still early days, but we want to have something that looks similar to what you'd see in a set of reports in either intraday or end of day. So this will generate these reports, and these are just the report definitions, as you can imagine. And this is it. Now you're kind of more or less in the system as such. So I'm just going to give you a very quick tour of what's available. We'll probably bump into some issues, but should at least give you some idea of what's going on. Actually, maybe I'll show you some of these features from the super admin. So the first menu you've got is identity, and in identity you can see, because I'm super admin, I can see all the accounts in the system. So what you can see here is all the accounts which the super admin, which are associated with tenant 0. In this particular case, these accounts are all accounts related to services and the super admin account itself. There's a slight problem here. These accounts are actually logged in at present, but because they're slightly different, they're not showing up as logged in. But these are basically all the service accounts. If you are a tenant and you look for accounts, you will see a slightly different view. One thing I forgot to mention, which is useful. We use Postgres role level security in order to make sure that the data is all private across tenants. This sort of enforces that we don't go beyond the Chinese firewalls between parties, for example, and between tenants. So although we're seeing the same view, the view of the accounts, you can see that there's a very different set of accounts that are visible. The tenant admin can only see accounts with that tenant. So if you wanted to create a user account, you'd be able to just create a user account here via the usual sort of menus. I'm not going to bother with that right now. You can also see the roles that are available in the system with their permissions. So we've got basic RBAC going on at the moment, which enables you to control permissions. Again, RBAC is supposed to work together with RLS to provide the security. So in theory, we should have a good security model. There'll be, of course, bugs and so on, but in theory, the security model should be strong enough to be, once the bugs are finished, to be addressed, to address security needs. And so here, as the roots, I can see all the different tenants, and of course, as a tenant, I can see myself. In fact, to be honest, no. As a system admin, as a tenant admin, you can also see the root tenant. But if there was another tenant, which you can create in the future, you wouldn't be able to see that. So that's expected. The reason why is because the system admin contains data, what we call data catalogs, that we need to publish from the system tenant over to other tenants. For example, I'll just do a quick sort of bypass here. So if I go up to the librarian, which I believe I just recently removed from the menus. I just, unfortunately, this software is moving very, very quickly, and even myself because I use the AI quite extensively for this. Even myself sometimes get a bit lost. There used to be a menu entry here for the data librarian, but it seems to have gone missing. So the data librarian contains all the catalogs in the system, and the catalogs was what I mentioned before, as just the bundles of data that we have obtained, open source data, they're available externally, things like Glaive, FPML, and so on. And we've put them as bundles already available in the system, so that we don't spend too much time entering that sort of data, and also so that the data in the system is realistic. So the data is stored in sort of the system party, and then within each tenant, you can then use the librarian to install the data onto that tenant. But because we've already used the wizards, we don't need to go to the librarian. But if you'd like to install something else, you can use the librarian for that. So that's the role of System 0 here, and so on. And so if I was in System 0, I could onboard a different tenant. So next, we've got different kinds of ref data. It's interesting that it's a bit slow to load the reference data. I need to look into why this is, because in theory it should be pretty quick, because services are running locally in this machine, and everything is sort of zero network hops. So it should really be much faster than it is at the moment to load ref data. I'm not quite sure why that is. I need to investigate. But you can see here we've got different currencies and different countries. We still haven't got currency pairs, but we've got other things in the rough data. As I say, there's some slight delay. Oh no, there's something already. A lot of this data is sourced from ORE. Some of it is sourced from FPML and so on. Basically, wherever we can find the sources, we use that data. That's pretty much everything in ref data. One thing I forgot to mention is we are already using a change reason based model. So if every time you make a change, we track that change. And if you're familiar with exotic trading systems, you know the importance of provenance and so on. So for example, let's say I decide to make a change here to our Brunei dollar, and then I save. It asks me to provide an explanation for the change. Let's say I say it's a rectification. I don't need to provide any explanation there. And then, interestingly enough, we should have received a notification here that something has changed. But I think something. Unfortunately, this is one of the problems of working with a system that's changing quite frequently. So the system uses an event-based system. So in theory, you can see all the events coming through, and what should have happened, that didn't happen, is whenever you do a save, I'll do exactly what I just did, an event is published, and as you can see here, there's a slight problem here. So an event should have been published saying that this data is changed, which will then trigger the reload button to go yellow. I think I must have recently broken this. And then you'd reload the data, you can see it flashing, telling you we've changed. You can see that we're now on version 5. And the Brunei dollar is now back to what it was before. I wonder if this break is across all entities or if it's specific to currencies. I may have done something that broke this. Yeah, I think our eventing is broken at the moment. I'll have to look into what that is. But as you can see here, we just did a change, and you can see now that I show up as the modifier. So, in fact, I don't want to make this too long a video, to be fair. Maybe we'll break. I'll just talk a little bit about ref data and org data, and then maybe we'll do a break to then talk about compute in a separate video, I think, because otherwise it's going to be too long. So, as part of the data that we loaded in our bundle, we also loaded data related to parties, data related to counterparties, interesting. I thought we had loaded counterparty data. Okay, I'll have to look at this. But you can load the counterparty. Oh, perhaps it's because we didn't initialize the counterparty data. The cursor of the demos. I was expecting to see some counterparty data here, actually. I'll have to investigate that, but it will be very similar to what you see here in the parties, and it will show all the parties we can trade against. Then we have things like business centers and business units, which are again also populated by our, well, business centers actually comes from FEML. Business units is populated via our data, sample data. And if you want to put it all together, you can see this in the Portfolio Explorer, which also generates a series of portfolios and books, which are these guys here. And you can see this is just basically a standard book structure that AI came up with. And you can then start to add trades to each of these levels, or the portfolio structure. Notice that you can only add trades to books. So in here you should be able to import ORE data. Now this feature is definitely going to be a bit problematic because I am, as we speak, working on it. So I suspect you're going to have problems with this, but nonetheless, I am going to attempt. I'm going to choose a small sample. And so this is going to, at present we don't import all of the ORE data because we don't have importers for everything, but we import some of it. So as you can see here, our problems with counterparties is actually going to be an issue because we have no counterparty to assign it to. Although having said that, I believe we can leave it blank for now, so we'll just leave it blank. This is something that validation will stop in the future. And as predicted, looks like. So, okay, unfortunately, this is the problem at the moment, is that I am in the middle of a sprint and I'm doing a lot of changes at present, and I must have broken something here. So if everything had worked as expected, you would have now seen the data coming in here. I suspect something in validation is failing at the moment. So I won't actually demo the Portfolio Explorer properly here. I will demo that in the next video. But this is the gist of it, basically. I think probably enough for this video, really. Or perhaps a couple of other things I may mention as well. So I mentioned a second ago that we had the notion of the reports. This is something we're actively working on at the moment as well. As you can see here, when you generate the system, it generates a number of report definitions that you can then use and instantiate. So for instance, we could choose something like an headline position, which is frequent enough. And we could so this contains the sort of the schedule for this report. It gives you some explanation what the role of the report is, the policies, and so on. And you can schedule it via cron, as you can see here. So, for example, if I click on schedule here, as you can see, the events are working correctly for this. I'm not entirely sure, although it's not coming through in our event. But at any rate, the events kicked in for this, and then you can see the report that has been scheduled. And then hopefully, if you go to the scheduler, you can now start to see that this report is going to start ticking. So in other words, every 10 minutes or so, this report will attempt to schedule. Now, this is currently, we're currently working on this as we speak, so there are still a lot of issues with all this work. But the objective at present is to be able to join the dots between the report generation, the retrieval of the data, the creation of the bundle, sending of the bundle into compute, and then to value that and obtain the results. This is still disconnected. The pipeline is still disconnected, and I'm kind of working on it at present. There's still quite a few releases to go, but that's kind of the gist of it. And then if you want to come from the compute end, you can simulate. What we'll do is, in fact, I think I'll do this as system, I think. So if I just close. So if I come from the compute end, you can see that I've got 5 hosts in my grid here. So what I'll do is just go up to the console here, and then I'll just upload my ORE binaries because these are not hard-coded, so you need to here's the ORE package. We'll just upload this package. Oh, Okay. Unfortunately, okay. There's a I'll do this in the next video. There's a configuration here. So we got two issues that we'll fix before the next video. The counterparties update didn't work, and then there's a configuration here issue. So what's happening at the moment is, in order to upload the package, you need the storage service to be configured correctly. And what's happening, I'm not entirely sure why, to be fair, but what is happening is, if we have a quick look at our env script, you should see that the storage service, well, in fact, the generic HTTP endpoint needs to be configured here. And I do not see the endpoint here. So I think there's some kind of issue with the way that the environment has been set up. So I'll have to look at that later. But what should have happened there is we should have uploaded the package over to the storage. And then once that's done, we'd be able to then start submitting tasks. So I'll do both of those things in the next video rather than this one. And well, there's all sorts of other bits and pieces here, but I'm not going to spend too much time with all the functionality, because it probably makes more sense to cover these bits and pieces as we start progressing in the application, as the functionality starts to join together. At present, it's a bit disjointed, and that's one of the things that I was quite keen on trying to finish before I could have a conversation with any members of the community in the ORE user meetup. So I think I'll just finish the video for now. It's also quite long. And then on the next video, I'll fix those issues and then demonstrate how to run a very simple job in the compute grid. Okay, thanks for watching.